In this problem, we're given the waveforms for the voltage as a function of time on the primary and secondary coils of a step-up transformer. So it's as if we have an oscilloscope hooked up to each side of the transformer. And we're asked a whole series of questions about interpreting these graphs. Now, unfortunately, when I imported these graphics, the numbers became too fuzzy to read. This is really a graph reading exercise. And that high point there is a 3 for the primary coil, and this low point is a -3. This high point for the secondary coil is a 5. And this low point is a -5. Also, on my time axis, it's hard to see the grid lines, but I have a 1 right there, 2 right there, 3 right there, and so on. Same thing for my secondary voltage. We're told our vertical axis has units of millivolts, and the horizontal axis has units of milliseconds. Question A asks us for the frequency of the signal. And so what I do is I can read the period off the graph, and one wiggle is complete after 2 grid lines, which is 2 milliseconds. So my period is 2 milliseconds. I could also write that as 0.002 seconds. And my frequency is the reciprocal of that. And I get a 500 hertz frequency. Next, in question B, this is just another graph reading question. I want the peak voltage in each coil. So that's the voltage amplitude. And in the primary, that's 3 millivolts. I guess I could write it this way, or I could write it in volts as 0.003 volts. In the secondary, it's 5 millivolts. Then we get into some short calculations. So assuming the primary coil has 200 turns, so I'm going to write down NP equals 200. And the transformer is ideal, compute the number of turns in the secondary coil. So what I mean by ideal is that the transformer equation is going to work exactly. So just quoting the transformer equation real quick. I solve for the number of turns in the secondary coil. NS is going to be NP. That's the number of turns in the primary coil times VS over VP. That's 200 times 5 millivolts over 3 millivolts. The units cancel, so I don't have to worry about that. I'm just writing 5/3. And when I run the numbers, I get 333 turns. Or I could say NS is equal to 333. Finally, assuming the current is 10 milliamps in the primary, and the transformer is ideal, meaning energy is conserved in this case, because the relationship between current and the number of coils was derived by using conservation of energy. Compute the peak current output from the secondary. Okay, so I write down the relationship between current and the number of turns and solve for the current in the secondary and plug in the number of turns in the primary. That's 200. Number of turns in the secondary, 333. And the current in the primary will have units of milliamps, and we'll just express our final answer in the same units. And I get 6 milliamps for the output current. So as with any step-up transformer, the output is coming out at a higher voltage, but you get a smaller current. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.